Jai Jinendra, Namaste and welcome to my channel. Today we are going to discuss the 44th question of the problem solving series and the 4th question of the stack data structure problem. The difficulty level for this question is medium and this question has been asked in Flipkart, Amazon, Walmart, Microsoft, Goldman Sachs and many other companies. So let's discuss. Get minimum element from the stack in order one time. Okay, so we have we need to design a class which has a stack data structure in it, and our class and we need to define these three functions: push, pop and get min. So when we insert any element into the stack, so we call the push function. When we pop out element in the stack, we call the pop function. And when we want to get the minimum element that is present in the stack, we call the get min function. So let's look at this example. So we call this push function. So if this is the stack in this solution, so we can call solution dot so this st dot this function, since it's a public function, right? St dot push, st dot push 2, st dot push 3, like that. So we have a stack. Okay, so we know stack is a last in first round data structure. Okay, so this is our stack. Okay, so now we have, in the beginning we have pushed 2 into the stack. Okay, then we have pushed 3 into the stack. Okay, done. Now we are popping out from the stack. So what do we pop out? The top element from the stack. So 3 gets popped out from the stack. Okay, now what do we have in stack? 2. Now we have a get min function. So this get min function, its task is to return the minimum element that is present in the stack. Now we only have one element that is present in the stack, that is 2. So obviously it would be the minimum element. So we have 2 in our output in the beginning. Okay, this get min returns 2. Now we have push 1. So what do? We push 1. Now we have get min function called again. In this get min function, now we have 2 and 1. In this stack we have 2 and 1. We need to return the minimum element that is present in this stack. It could have been, if in place of 1, if it was returned 5, then our answer would have been 2. But between 1 and 2, which is the minimum element? 1. So our answer is 1. So this is the output that is going to come. So now we need to design our class. So it looks very simple. We just push the element in the stack, pop the top element from the stack, and then in min function we check in the stack which is the minimum element and we return the minimum element. What would be the time complexity? It would be order of n. In max, say it would be order of n in the worst time, because if all the elements are pushed into the stack, see, we have n number of elements in the stack, and then we search it linearly which is the minimum element, and we get the minimum and we return it. So it takes order of n time to get the minimum element, but the question is we need to return it in order of 1. In one operation we need to find the minimum element. So how do we do this now? What could be the logic? We will have elements in the stack. We don't know what is the minimum element. We know to get a minimum or the max element from any array or a list, we need to traverse it and need to find out the minimum max element, right? If it is sorted, then we can apply binary search and we can return it in order of log n, but it's not sorted. So it would be order of n, but we need to return it in order of 1. How can we do it? How can we code these functions so that we get our this get min call is in order of 1? So let's try. Let's think. Okay, let me code this and let's see if this code works for all the cases or not. Okay, what I'll do, so let's code the push function. What do? We push the element, right? X is present here, so we'll push it. So before, what can we do? we have this stack defined in this solution class. Okay, so let's try to code it like this. Say if stack is empty, right? In the beginning, the stack would be empty, right? So if at every point of time, whenever I am pushing or popping out, if I have the minimum element found out every time, then when we go into the get min, this has to be written in order of 1. Here we are pushing and popping, it is order of 1 only, but this get min has to be in order of 1. This get min can be in order of 1 when we know the minimum element is found before only, right? So can we do something like this, that if the stack is empty, we know the minimum element in the stack would be this element, right? Of course, right? And we will push this x into the stack. Okay. But if it's not the case, if there is here in this case 2 is pushed and then 3 is pushed, right? So 2 is already pushed and then 3 comes. So now our stack is not empty. At that point of time, what can we do? What is the next element? 3. So 3 is actually greater than 2, right? So our minimum element still would be 2. But what if here in case of 2, 1 has come? Then our minimum element has changed. Now 1 is the new minimum element, right? So if every time I find out the minimum element, but say 2, 1, 4, 3, I can't keep comparing it, right? Okay, I can get the minimum element while I'm pushing it, right? Every time I'm getting the minimum, okay, currently this is the minimum element. But what if when I'm popping it out and I'm popping out the minimum element, then we can't get our minimum in the order of 1 operation, right? So here, if this code function is very simple, if stack is empty, okay, then what do we return? If stack is empty, then I'm switching the context, but it won't be any difficulty for you to understand. So if only get min has to be, say we have got the minimum element, right? So what would be the get min function? How would we code it? If stack is empty, then we don't have anything to, we don't have the minimum element, right? So in that case, it's given in the question that you return -1. Or else what do you do? Else you return min. So this is done, right? Now I need to find this min every time, right? At every point I have to have this min ready, right? Whenever I'm pushing and popping it out. So if I'm pushing it out, I'm comparing every time, I can have the minimum element every time, right? I can compare, okay, at this point of time, this is the minimum, this is the minimum element. But if that element gets popped out, then it could be an issue, right? So how mathematically we can solve this? We'll use a logic that will help us to solve it. Okay, let me write the logic first, and then I'll derive it. And we have a, I'll give a dry run for this example or any other example, okay? So here stack is empty, the minimum element is that we have pushed this x into the stack, right? Now if stack is not empty, else if stack is not empty and stack dot top is actually greater than the new element that has come, what will happen? Or not stack that dot top, okay? The minimum element that is there currently, if whatever the minimum element we have, if it is greater than x, then we need to change our minimum value, right? So what do? We will insert into this, we will make min is equal to the current min value, right? Because this is lesser than this. If min is greater than x, then our new min is x. But in stack, we will insert 2 into x minus mean. Okay. Now why I have done this? Okay. We'll come to it, discuss it after some time, right? But say in this example, okay, 2, 3 is a different example, but 2 into x minus mean, will it be always less than x or not? Say minimum was 2, okay. Now the next element that has come is is 1. Okay, here minimum is 3. Here in this case 3 is popped out. Okay, let's take another example. So minimum is say 3. Okay, say 5, and now the next element that has been inserted is x, which is 3. Okay, so I make the mean as 3. Okay, but what do I push in the stack? The stack has 5. Okay, and it could be some other element, 7, 8, 9 greater than 5. Okay, but what do I push into the stack? 2 into x minus mean. Okay, so what is x? So I will make this mean is equal to x after pushing this. Okay, mean is equal to x. Okay, mean is equal to x. Yes. Okay, or otherwise I will push stack the element in the stack. If it is greater than mean, then I don't have any problem. I'll push this. Okay, so this is coded. Okay, so what I wanted to say is that 5 is there, then 3 has come. In the stack I am pushing 2 into 3 minus 5, that is 6 minus 5 equal to 1. So in the stack 1 goes. This 1 is actually less than the minimum element. I am pushing the more smaller element into the stack, and this will always be, this 2 into x minus mean will always be less than x, the actual minimum element. Of course, logically you can think, because mean is greater, right? So double of x. So x plus x minus mean. X minus mean will be negative. So this number will be anyways be lesser than x. Okay. So this we will push this 2 into x minus mean into the stack. Okay. So the stack will have 5 and 1 here in this example. Okay. Now, so this is coded. If minimum is if x is greater than minimum, we don't have any problem only. Keep it, insert it into the stack, because I have already the minimum element in my hand. Okay. Now pop function. What do I do in the pop function? So here, so I have elements. Okay. Now if the stack dot top. Okay. If the stack dot top is greater than x, greater than the minimum element, will I have any problem if stack is greater than equal to minimum element? No problem, right? I'll pop it, because my minimum value is not going to change. But if stack dot top is less than the minimum element, in this case, okay, then what is the thing? What do I need to do? If stack dot top is less than the minimum element, that means I am actually popping out the minimum element, right? I am popping out the minimum element. So if I pop out this one after, like, 5 has been inserted, 3 has been inserted, and then I am popping out 3. So if the minimum element is popped out, I need to get the previous minimum that I had, which is 5, right? So I need to change, because my minimum element is going to be removed, right? So what do I need to do? I need to get back my original value, which is 5 in this case. So if this is the case, what I will do, I will have int t or temp equal to s dot top, okay, and my minimum value would become 2 into 10 2 into 10 2 into mean minus 10. This will be my minimum value. How? I'll explain. Okay. And then what do? I will just okay, this is done. Fine, and I'll just pop it. Either if this condition is true or false, we need to pop this. So no problem. I have popped the element. If this condition is not false, then also I need to pop it out. Okay. So this 10 value will be removed from the h dot top, and I'll have my mean value changed. Now let's see this example. What was the value of the mean? Mean was the actual mean 3. Okay. Now we have 5 and 1 in the stack. Actually we have inserted 5 and 3 in the stack. But now when we are popping it out, I am removing 3, and my next minimum has to change to back to 5. Okay. So with this operation, 2 into mean. So what is the mean value? 3. And what is the 10 value? 10 value is 1, because this has been popped out. So 2 into 3, 6 minus 1 is 5. So I have got this 5. Did you understand? Huh? I'm not very sure whether you understood or not. I'll prove this approach again. Okay. So this way, this push is done, pop is done, and get mean is also done. So if I run this example on this test case, okay. Let me try to run another example in this test case. Okay. Say, let's see this example. The same one. Okay. Push 5. Okay. Then get mean. Push 3. Get mean. Pop. Get mean. Pop. Get mean. So what would be the answer for this? 5 is pushed. Okay. Get minimum. What is the minimum? 5. 3 is pushed. What is the minimum? 3. Pop out. 3 is popped out. What is the minimum? 5. Okay. And get mean, 5 is popped out. What is the minimum? -1. So 5, 3, 5, -1 should be the answer. And we will run this example in this code. Okay. We have got 5. So we push 5 into the stack. Let's see. This is the stack set. Okay. So we have pushed 5 into the stack. Okay, why? Because stack is empty. So we have pushed 5 into the stack, and our mean value is 5. Okay, mean value is, let's remove this. Mean value is 5. Okay, in the first step. Okay. Now get minimum. Get minimum is called, what do we do? Stack is empty. Stack is not empty. So what do we return? Return 5. So 5 gets returned. Okay. So our answer, here 5 gets printed. Okay. Answer in the first place. Now in the stack 5 is there. Now we have 3. Okay. Now this function gets called. Stack is empty. Stack is not empty. So we will move in the else if condition. Okay. Now in else if condition, what is the value of mean? Mean is 5. 5 greater than 3? 5 is greater than 3, right? So we have got a new minimum value. So what do we do here? We will insert 2 into 3 minus 5. Okay. 2 into 3 minus 5 is 1. Okay. So in the stack, this 1 will be inserted. 2 into 3 minus 5. And what would be our mean value? Mean value would become x, which is 3. So the new mean value would become changed from 5 So earlier it was 5, this is changed and now it is 3. Got it? For new value, mean value has been changed. Okay, so now in this get mean value, we will check the mean value which is 3 and we will return 3. So another thing what I wanted to note is this change value 1 is always less than the minimum value. Okay, what we insert into the stack will be lesser than this because we are subtracting, we are doubling this x value and we are subtracting the value which is greater than this x. So obviously it would reduce from x. Okay, normal logic. So 5 and 1 is in the stack. We have got this. We have got the get mean from mean. We call this and we return 3. So 5 and 3 have been printed. Now what do? We pop out. Okay. So pop function is called first time, and we see what is there in this pop function. If the whatever there is in the stack, the top of the stack, this 1, this will be popped out, right? And if it is less than mean, so mean is 3, 1 is less than 3. If it was not less than the minimum value, if it would have been popped out, will our minimum value change? No, right? But when it is less than 3, that means we knew what we inserted into the stack is actually lesser than the minimum value, which is a problem. That's why we use this logic. We can't remove the, if we are removing the minimum element from the stack, then we need to get back to the previous minimum, right? Which was 5. So we came to the conclusion here that in stack top, if it is less than the minimum value, we need to get the previous minimum value, right? So temp is equal to, we got the current minimum value which is in the stack. So we have this temp is equal to 1. And to get that value, the previous mean value, we will just reverse this operation. So the new mean will become 2 into mean minus temp. So what is the mean value? Mean value is 3. And what was the temp value? Temp value was 1. Okay. So 2 into 3 minus 1, 6 minus 1 is equal to 5. So our mean value again changes to 5. And we pop out this 1 from the stack. Okay. This gets removed from the stack. Okay. And our mean value is 5. Done. Now again we get a get mean call. Okay. So what do get mean will do? Get mean will return the minimum element. What is the minimum value? Minimum value is 5. Current minimum value. So 5. Now we are popping. So get mean is done. This get mean is done. Now we are popping out. Okay. So when we are popping out, we see stack is empty. So we pop out. Okay. So stack dot top. What is there in the stack dot top? 5. And 5 is not less than 5, right? So this condition will not come. Okay. And we will just pop out. Okay. Because stack dot top is 5 and min is also 5, right? So it will not come. 5 is less than 5. So since this condition can only happen when there is only equal to this is equal to, right? So this condition will not come here and we will pop the element. So 5 will be popped out. Okay. And if it is popped out, our mean value is not changing. Okay. So no issue because stack is empty, right? So this will anyways work. So 5 is popped out, the stack is empty, and then this is done. So stack becomes empty and mean value is still 5. Mean value has not changed, but it actually should be minus 1, but it would be automatically minus 1 because the stack is empty. Okay, so this is done. When we call again get mean, we see the stack is empty and we will return minus 1. So this is minus 1. So this is our answer and this is done. And I hope that this mathematical logic, what we have inserted into the stack, this is clear. So in this way, we can solve this problem in order of 1 time complexity. Okay, this get mean operation. Okay. This has become like very difficult to understand here while looking at this, but I've explained all the logic that is required in this question. I hope everything is clear. The link to the question has been given in the description. Please try it yourself now before coming back to my code walkthrough section in the later part of the video. Here is the code walkthrough of the get minimum element from stack problem. So as you can see, this is the question here. The question is mentioned in the description, and I have coded this solution class. We have this minimum element stack, and this is the get min function as we have discussed already. This is the pop logic. Okay, so we are actually returning whatever it's popped here in this case, just in this function, but the normal main program won't return it, so not an issue. If it is empty, we are returning -1, so it's not an issue. Okay, the logic is same. You can see here, if it is less than, then we make the minimum element as 2 into minimum element minus t. Otherwise whatever returned is remains same, so we are returning whatever we have popped out. That is the difference just. And in the push, we are doing the same thing as discussed. If it is empty, we have this minimum element, we push the element into the stack. Else if it is the element that has come is less than the minimum element, we push 2 into x minus minimum element, which actually becomes lesser than the actual minimum element that we push, and we get our minimum element. Otherwise we just push it, because if it is greater than minimum element, we don't have any problem. Okay, so yeah, this is the Geeks for Geeks platform, and let's submit this directly. So yeah, all the test cases have passed. I hope the explanation, code walkthrough, everything is very clear. Okay, then see you all soon in the next video, where I'll be explaining the 45th question of the problem solving series and the 5th question of the stack. Thank you.